Okay, friendly neighborhood mad scientist here. I'm going to go over some dot diagrams with you. I've noticed that on our first assignment due last Friday, didn't get much response. Those responses that I did get were a little bit confused, but some of us do have this down, so not a hopeless situation. We are going to take a look at, and I'm more interested in the fact that I also gave you its chemical formula at the same time. And there's a hint within this chemical formula that I'd like to pay attention to. I put carbon in the middle for a very good reason. It's going to hold everything together. But before we get to that, the first thing that we need to do is to decide how many dots. You do not need to show me all of these steps. You do need to show me the total number of dots that you anticipate, so that if I misread a dot, I can go back and say, oh, yes, you had the right number of dots. Let me give you full credit for that. Or no, you didn't have the correct number of dots calculated. So I'm deducting points for the fact that you did not tell me this. So we all want to start at that point. Okay, we put carbon in the middle because it forms 4 bonds. The closer I am to the middle of the table, the diagram to which you put all those dot diagrams last week, closer you are to the middle, that's the element that's going to be in the center of your molecule. I'm going to put my hydrogens and my chlorines in a pattern that does not make a difference. I could have put my chlorines where my hydrogens are. I could have put chlorines top and bottom, the hydrogens right to left. It does not matter. But now I need to know something about electronegativity. That is to say, how close are you to the right edge of the periodic table? Well, it turns out that chlorine has a higher electronegativity than carbon or hydrogen. I begin there. Now, I'm simply using the convention that we saw for our 3D model kits, which is to say that we use color for certain elements, and green certainly be the case for chlorine. And notice that I'm starting just with 7 dots. I'm going to add an 8th dot to each of those, but those dots are going to have come from carbon. Notice I've completed the octet on my 2 carbons first. 2 octets, that's 8 times 2, that's 16. I'm still 4 dots short of the 20 that I need. So I need 4 more dots. 4 dots more. And they're coming now. Because carbon, the black ones represent the 4 dots that carbon brought up to the whole scheme of things. And I'm going to use a different color just because white's not going to show up. But here's my hydrogen, and 1 dot from each of those hydrogens. Now, it is not at all important that you distinguish which element brought which dot. That's not relevant. But I thought I'd illustrate that 7 dots are coming from each of the chlorine atoms. That's why you see 7 green dots around each chlorine atom. 4 dots coming from carbon, those are the black. 2 dots are coming from hydrogen, those are the gray. And so altogether, now I do have all 20 of the dots that I'm supposed to have. This is the complete dot diagram. Notice I didn't use lines. Lines are okay, but for our purposes, I want to make certain that you're using dots correctly at this time. So let me write down the steps that we just went through to get to this point. We counted dots. And report your count. That's step 1, always. Step 2, assign the central atom as the one that makes the most bonds. That is always the case. Our central atom is the one that makes the greatest number of bonds. Octet on outer atoms first. chlorine before carbon, simply because it's on the outside. A duet on hydrogen, and check the dot count. Now, the next thing that we're going to do was not asked of this particular assignment. 109.5-degree angles. I have a tetrahedron. I'm going to put hydrogens here and chlorines there, but it would certainly not be incorrect for me to draw this from any particular perspective. And any of these would be perfectly acceptable as 3D sketches for methylene chloride. Please include at least one indication, well, actually only one indication, otherwise it's going to get very messy, of what bond angle you have there. So that's methylene chloride, pretty straightforward one. I'm going to do another one that also tripped us up separately.